Friday was factoring trinomials. Well, we're going to go over that today. Okay? We're going to go over it again because it's very, very important. All right. So the first thing we need to try to identify is a greatest common factor. Now that means that we need to look at the letters and the numbers involved. In this trinomial here, is there a greatest common factor? 2. Okay? I can factor a 2 out of that trinomial, and it leaves me with another trinomial, 2x squared plus 3x plus 1. Now I need to decide if I can take what's in that set of parentheses and break it down even further. All right, so how did we do this last week? What did we talk about? We start with our first and our last term, and we list out factors of the first term, one on top of the other. What are factors of 2x squared? 2x and x, right? Then we list out factors of the last term, which is 1. The only factors of 1 are 1 and 1. And what did we do to be able to try to figure out if these were correct, if they were in the right place, and what the signs had to be? Cross multiply. All right, we cross multiply here, 2x times 1. And then from here to here, 1 times x. And we ask ourselves, because remember this is our key sign, do these two terms add up to 3? Yes. How can I make them add up to plus 3? If they're both positive. And then we said the first sign that we see here, like we're reading across a page, goes in the first group that we created. And the second, which the signs are the same, so it really doesn't matter. All right? So we have just found all the factors of that original trinomial. But what's the proper way to write this thing? Now look, this is like a puzzle. Okay? Think about making puzzles. All right? When you take the puzzle apart, you need to make sure you still have all the pieces, right? Because if you want to put it back together eventually and you're missing some pieces, you're not going to be able to get the complete picture. Same thing here. There are 3 pieces to that puzzle. We started by factoring out a 2. That is a piece of the puzzle. So, that's our first piece. Then we took what was in the parentheses and we factored it into 2 more pieces, right? Well, we're going to list out those pieces. 2x plus 1 times x plus 1. And that would be your final answer. And it is factored completely. So when you take out a greatest common factor, don't just think, oh, it's gone. It's still there. It's a very important piece of that puzzle. Yes?
So you can never leave it, like your second step, you can never leave it like that?
No, you have to write it out side by side. Okay? This is just a shortcut to help us figure out what our 2 pieces are.
No, but you can't leave it as 2 and then...
This? No, it's not factored completely. That's like if I said we're working with fractions and I told you to simplify completely, and you took this and simplified it down to this and stopped. You can still go further. Okay? So when we say factor completely, you go until you can't go anymore. All right.
What was that called?
What? This? Factoring trinomials. Well, this is just factoring. Okay? This specific thing right here is trinomials. Now, you can use that method for any trinomial. All right? If Friday I said, look at this. If there's no number in front of here, all we've got to worry about is the 9 and the 6. Okay? And it was very simple. But if switching from one method to another method is throwing you off, we're doing the same thing in both cases. We are looking for factors of x and factors of 9 that when we put the products of those things together, they need to add up to 6. Well, how can 3x and 3x add up to negative 6? If they're both minus, right? So we have x minus 3 times x minus 3. And how could you write that since it's both exactly the same? X minus 3 with the square on the outside of the parentheses, not on the inside of the parentheses. All right, so what we're going to start doing right now is we're just going to do this every time so that we can get a standard form and a standard way of doing it so everybody's on the same page. All right? If you're good with just looking at this when there's no number here and saying factors of 9 that add up to 6, then you do that. All right? But I'm going to do it this way for anybody who's still having trouble with that. Here, it's a trinomial. First, look for a greatest common factor. Is there one? No. Okay? So let's go through our method. We find factors of x squared, factors of 6. We cross multiply. And we ask ourselves, will that add, this is very important, add up to 5? If they're both what? If they're both positive. Okay, so we've got x plus 3 times x plus 2. Would that still be the answer if this was a minus sign instead? No. So it is very important that you know how you're getting that middle term. Are you adding them or are you subtracting them to get that middle term? In this case, 3 and 2 are not the factors of 6 that I need to use because there's no way you can subtract 3 from 2 or 2 from 3 and get 5, is there? So what factors of 6 need to be used to factor this trinomial? 6 and 1. So I've got 6x, 1x, and if the 6 is plus and the 1 is minus, that gives me my middle term of positive 5x. So where do I put the plus sign? At the top. Minus sign at the bottom. This factored down to x plus 6 times x minus 1. Okay? So this is key. I would advise you before you even start factoring to circle it to identify. I'm going to be subtracting to get that middle term. Yes?
If it was still plus 6, could you use 1 and 6?
No, because there's no way you can add 1 and 6 and get 5. Okay? You have to, depending on that sign, because we're multiplying two signed numbers to get this. So if you're multiplying two signed numbers to get a negative, one has to be plus, one has to be minus, which means you're subtracting two numbers. But if you multiply two signed numbers to get a plus, then the signs have to be alike, which means you're taking the sum of those two numbers. Okay? So it's all intertwined together. First, look for greatest common factor. Is there one? No. Okay, you start your process. Now, there's several different factors of 12. But we need to find the ones that do what? Subtract or add? Subtract. To give us 4.